I am Janardhan, School Assistant Mathematics, Government High School, Banjara Hills, Road number 7. In this video, let us discuss properties of the logarithms. Properties of the logarithms. First one is the product rule. Let a, x and y be positive real numbers with a is not equal to 1. Then log xy to the base a is equal to log x to the base a plus log y to the base a. So let us prove. Let log x to the base a is equal to m. This is logarithmic form. Convert into exponential. A to the power of m is equal to x. And log y to the base x, log y to the base a is equal to n. That is equal to exponential form. A to the power of n is equal to y. And this x into y is multiplied. Xy is equal to x is equal to a to the power of n. Y is equal to a to the power of n. So this is a to the power of n and a to the power of m and n added, plus of indices. Xy is equal to a to the power of m plus n. So this is the exponential form. Convert into logarithm. Log xy to the base a is equal to m plus n. So here m value and n value is there. M value and n value, substitute in this. Log xy to the base a is equal to m is equal to log x to the base a plus n is equal to log y to the base a. This is the first property of the logarithms. The second one is the quotient rule. Let a, x and y be positive real numbers with a is not equal to 1. Then log x by y to the base a is equal to log x to the base a minus log y to the base a. Let us prove. Let log x to the base a is equal to m. This is the logarithmic form. Convert into exponential. A to the power of m is equal to x. And log y to the base a is equal to n implies exponential form. A to the power of n is equal to y. So this is x by y divided. X by y is equal to a to the power of m divided by a to the power of n. So laws of indices again apply here. X by y is equal to a to the power of m minus a to the power of n. So this is exponential notation and convert into logarithmic form. Log xy to the base a is equal to m minus n. Again m n value substituted. So log xy to the base a is equal to m is equal to log x to the base a minus n is equal to log y to the base a. This is the second property of the logarithms. Go to the third one, the power rule. The power rule is let a and x be positive real numbers with a is not equal to 0 and n be any real number. Then log x to the power of n to the base a is equal to, the exponent will be multiplied n log x to the base a. This is the third property of the logarithms. We can prove it. Let log x to the power of n to the base a is equal to p. Logarithmic form, convert into exponential. A to the power of p is equal to x to the power of n. And log x to the base a is equal to q. Again convert into exponential form. A to the power of q is equal to x. Here first equation, a to the power of p is equal to x to the power of n. You can take it a to the power of p is equal to x to the power of n. This implies, whereas a to the power of p, here x value substituted, x is equal to a to the power of q. A to the power of p is equal to, instead of x, a to the power of q whole to the power of n. Again this is the laws of indices. A to the power of p is equal to a to the power of q into n. This implies where the bases are equal, equate the powers. P is equal to q to the power of n. That implies p is again commutative property. Q into n is equal to n into q. So whereas p is equal to, already we in the proof we can take it p is equal to this one. Log x to the power of n is equal to a is equal to n into q. Q is equal to log x to the base a. So log x to the power of n to the base a is equal to n into log x to the base a. This is the third property of the logarithms. Some important rules of the logarithms we can see here. The first one is, we know that b to the power of 1 is equal to b. Convert into logarithmic form. Log b to the base b is equal to 1. Log value and base value is the same, the value will be the 1. Second one, we know that the b to the power of 0 is equal to 1. So convert into again logarithmic form. Log 1 to the base b is equal to 0. Log 1 to the base b is equal to 0. This means whatever the base, log 1 is always 0. We can do some problems among these properties of the logarithm. First one is expand log 1575. Log 1575. This is factorized. 1575 is factorized. Log 25 into 9 into 7. Log 25, 5 square, 5 into 5, and 9, 3 square, 3 into 3 into 7. Apply the first property of the logarithm. Log 5 square plus log 3 square plus log 7. So again apply third property of the logarithm. This 2 5 square will be the 2 into log 5 plus, here also third property, 2 into log 3 plus log 7. And another one is expand log 16 by 25. Here by divided by, this is the second property of the logarithm. Apply log 16 divided by 25. Log 16 minus log 25. Here divided by, we will get the minus. Log 16 is 2 to the power of 4 minus log 25 is 5 square. Here third property of the logarithm, the 4 is multiplied before, 4 into log 2 minus 2 into log 5. So previous two problems we expanded the logarithm, single logarithm. Here we convert into the single logarithm. Different logarithms are there. Apply the log first property of the logarithm and second property of the logarithm. We can apply this one, and third property also we can write it single form. So log 81 plus log 2 to the power of 4. So third property minus log 36. Third property, x to the power of n to the base a is equal to n into log x to the base a. Log 81 plus 2 power is equal to 16 minus log 36. And now for this 3, here plus is there, we can apply the first property, and here minus, we can apply the second property. Log 81 into 16, here minus is there, divided by 36. Log, here 36. 9 4s are 36, 9 9s are 81. Here 4 is left, 4 1s are 4, 4 4s are 16. Here we left it, cancellation, after cancellation 9 into 4 will left, log 9 into 4, 9 into 4 is 36, log 36. This equal to single logarithm is log 36. Now we can determine the value of the 5 log 5 to the base 25. Log 5 to the base 25. So let log 5 to the base 25 is equal to p. So this is the logarithm form. Convert into exponential. 25 to the power of p is equal to 5. 25 to the power of p is equal to 5. The 25 exponential form is 5 square is equal to 5. Apply the laws of indices. This will be the multiply. 5 to the power of 2p is equal to 5 to the power of 1. So where the bases are equal, equate the powers, 2p is equal to 1. So here 2 is multiplying, goes to the side, transfer to the side, 2 by 1 by 2. The p value is the 1 by 2. Therefore, log 5 to the base 25 is equal to 1 by 2. Do one more problem. This is to prove that if this is a given x square plus y square is equal to 18xy, then prove that the 2 log x minus y is equal to 4 log 2 plus log x plus log y. So this type of the problems are very important for SSC annual examination model. So what is the given? We can take this one. Given that x square plus y square is equal to 18xy. You see here they are asking x minus y. That's why you have convert into x minus y whole square form. Here a square, x square plus y square is there. If you want a minus b whole square form, add the minus 2xy on both sides, or subtract 2xy on both sides. Subtract 2xy on both sides. Here and both sides we can subtract. X square plus y square minus 2xy is equal to 18xy minus 2xy. The same manner, x square plus y square minus 2xy is equal to 18xy minus 2xy. So this is a minus b whole square form. X minus y whole square is equal to 18xy minus 2xy is equal to 18 minus 2 is equal to 16xy. So apply log on both sides. Log, this is x minus y whole square is equal to log 16xy. This is apply the third property of the logarithm. 2 log x minus y is equal to, this is the first property of the logarithm, log 16 plus log x plus log y. 2 log x minus y is equal to 16 is written as exponent notation. 2 to the power of 4 is equal to 16 plus log x plus log y. 2 log x minus y is equal to third property of the logarithm, 4 comes to here, 4 into log 2 plus log x plus log y. Hence proved is